Hello, this is John O.T. In this fourth part of the Magsimus Deluxe tutorial, we will define an external field that will act on the design we built up in part 3. We will run a calculation on the design and record and play back the calculation. We will conclude with a simple parametric calculation example. Here is the current state of our design from part 3. We use the external field controls here below the design manager to define the external field the design will be subjected to doing a calculation. We begin by checking the Use Field Definitions box here. By doing this, we are signaling that the external fields we shall presently define would be the ones to be applied to the system during a calculation. If this box were left unchecked, the solver would simply apply a field given by the data in the input boxes of the external field control. We click the Edit button. This displays the external field specification dialog box. External fields could be defined to act on all components of the system, as well as on components of selected groups. For the latter, we need to choose the option Group Level here in the Select Field Scope frame, and then select a group from the Select Group box. In this instance, we will be applying only a system level field. So we leave the system level option selected. A field definition is made up of a sequence of field legs. Field legs and their types are discussed in detail in the user manual. By specifying several field legs of different types, we can apply complicated fields to a system. Here we will define an external field consisting of just one leg. This will be a loop field. We select loop in the field type box. An appropriate input configuration is displayed in this area to the left. We add the field leg by clicking the Add button. Let us enter data for the loop field. We click OK to exit the dialog box. We are finally set to carry out a calculation on our design. Let us, however, take one quick look at the System Properties dialog box. We can bring it up by double-clicking the System node. As usual, related input areas are organized under separate tabs. Under the Calculation Control tab, notice that the static calculation method is selected. This is a calculation that is based on the assumption that magnetization processes are independent of time. With this choice, data input specifications and generated output data are both independent of time. Calculation methods are discussed in detail in the user manual. Design and computational units can be specified under the Units tab. Let us quit the dialog box. We begin a calculation by clicking the Run button. This will invoke the solver to compute the electromagnetic behavior of our design. Let us click it. Let us pause the calculation briefly by clicking the pause button. The plot windows for the output curve that we defined for the various components of the design have now been launched here. In this box, in the external field controls, the evolution of the externally applied field is displayed. The electrical circuit and mechanical motions we defined for our system have also kicked in. We click the Continue button to finish the calculation. We observe the evolution of the system states as the calculation progresses. The magnetizations interact with each other and with the magnetic field produced by the electrical currents. Offline, we moved and resized the output windows a bit for clarity. Let us repeat the calculation. This time, we will record it. Recording means that we will store the sequence of solution states of the calculation so that they can be replayed back. This is an extremely valuable feature for detailed post-analysis of designs. Before we repeat the calculation, we first click the record button, this one. We are now ready to record the calculation. We click Run, and there goes the calculation again. I will resume the narration when the calculation ends. Here we are at the end of the calculation. The forward replay button is enabled. We click it to replay the saved calculation in the natural forward direction. Notice how a movie of the calculation is played out. Clicking the back replay button plays the recording backwards. Clicking this button, the jump to a frame button, allows us to specify a random playback frame or stored data position to jump to. For example, this entry takes us to the 35th frame. There is much more to the recording controls. Refer to the user manual or the context-sensitive help for more details. Let us finish up by saving this design to file. There. We will now illustrate Magsimus Deluxe parametric simulation capability using a simple design example. A parametric simulation is one that is repeated several times using different values of one or more design properties or parameters which are varied systematically. This procedure is referred to as parameter sweeping. Let us start a new design. To this one group, we add an element. Under the Magnetic Anisotropy tab, we define a uniaxial magnetic anisotropy for the component. We click the Define New button, making sure the uniaxial option is selected. We enter the anisotropy data. Under the Data Output tab, we define an image curve for the component. We click OK to exit the dialog box. We click the Zoom Full button to blow up the display. Let us use the System Pane shortcut menu to display the depiction of the magnetic anisotropy we defined. There. Here it is. The double-tipped arrow coincides with the z-axis for this anisotropy. Next, let us specify a loop external field to be applied to the design. There. We now switch over to the next tab to specify the properties of our parametric simulation. We begin by checking the Generate Parametric data box. The class of parameters to vary is selected in the parameter category frame. We select the System External Field option. The parameters that can be varied for the chosen data category are listed in the source box. We will vary the polar angular direction from 0 to 90 degrees in 10 steps. We select polar angle. We transfer it to the target box by clicking this button. We can specify all the parameters we want to vary this way. We enter the sweep values. We click OK to exit the dialog box. We start the calculation by clicking the Run button. After a few seconds, the parametric output window is displayed, this one here. Let us pause the calculation for a while. Observe how different image loops are traced out as a function of the field direction that can be observed changing here. Let us continue and finish the calculation. I will resume the narration when the calculation ends. Here we are at the end of the calculation. This is the surface plot generated by the calculation. We right-click it with the mouse button, and from its shortcut menu we can do several things. We can show a cutting plane. Here is a trace of the cut. We can change the orientation of the cutting plane here, and we can use this slider to reposition them. There we have it. This file shows a summary of the various parts of a typical Magsimus Deluxe session. And here is a list of useful productivity tools that are accessible to you. And with that, we come to the end of part 4 of the Magsimus Deluxe tutorial. Here is a recap of what we learned. Moving forward, you could use our in-depth video tutorials and topical design demos to learn more. Thank you.